Okay, welcome back. So the first demonstration that we are going to do is on the top-down parsing, or we call it recursive descent parsing. So the idea is, if you are given with a sentence, the parser, what it does is, rather than starting from the sentence, it's going to look into the starting symbol, or what we call is S in your context-free grammar, and it will, iteratively break it down into smaller pieces until it arrive at the words. Then whenever it find the word, it will try to match it with the input text that we have. So in NLTK, you can run this, this code in NLTK to see how the recursive distance parsing work, which is the top-down parsing method that we have. So I'm going to switch to NLTK to show you how this works. Okay. I hope that you can see the Python interpreter, right? Tayyad?
Yes.
Okay, very good. So this is what we do, okay? Because we are going to see how recursive distance parsing works in NLTK. So we're going to do import NLTK. Okay, first we have to bring every package from NLTK. Okay, let's give it some some seconds. Until all the packages are brought here. Mind you, when you do this demonstration of recursive distance, or even the shift reduce parser, another window is going to be open to show you how the parser works. Okay. Okay, now we have it in here. So to see how the recursive distance works, this is what we do from NLTK. We are going to have app, means the one that has the what we call the demo, then recursive distance and parser. Okay, so we are going to call this demo. Sorry. Just a moment. Yes. Okay, let me change the window. Another window would be opened. As you can see, this is whenever you say recursive distance parser, this is a new window that will be opened. And as you can see, it's very good to, first let's increase the size so that you can see most of the things that we want you to see. So as you can see in here, the demo for recursive distance has these important elements. As you can see on the left-hand side, what do we have? What do we have on the left-hand side? You can see that it's a grammar, right? If you remember, we talked about a grammar in chapter 2 when we discussed about syntax and parsing. So a grammar is for each and every word, as you can see in the bottom, for each and every word, we are assigning their part of speech. And for the others, we are trying to see the naming for each of the grouping. Like, for example, in here, 1, 2, 3, 4, in the fifth line, we are saying that if a verb is followed by a noun phrase, then we call it a verb phrase. At the fourth point, we said if a verb is followed by a noun phrase and followed by a prepositional phrase, we call it again a verb phrase. And if a determinant is followed by a noun, we call it a noun phrase. And this is what we call is a grammar. And this is what's expected or what's required in building a parser for a language. And at the bottom in here, as you can see, we have a sentence. And the sentence says, the dog saw a man in the park, okay? Now, using this grammar, what a parser does is it's going to validate whether this sentence is valid or not, okay? It would check whether this sentence is a valid sentence in the language. And that's what we want to know. That's what we want to do in parsing. If you remember, we said the definition of a parsing window number, it will help you to recognize and generate a structure. It will recognize the correctness of a sentence. Then after that, it will try to build a tree, a structured tree for that sentence. So as you can see, in a top-down approach, where do we start? We said it's going to start at the top, which is S ማለት ነው። ስለዚህ ምን ያደርጋል? Sን የት ያመጣዋል? It will bring it to the working area. እዚህ ጋር እንደምታየው it will bring it to the working area ማለት ነው። Let me point it in here. As you can see, የት ጋር ነው የሚያመጣልን? Just a moment. As you can see, እዚህ ጋር ይዞልን መጣ ማለት ነው። Sን አያችኋት? From the available grammar, it will bring it to the working area. And that's what we mean by, starting from the top. Then what do we know? We know that S, okay, which means a star symbol, based on this grammar, can be further subdivided into a noun phrase and a verb, okay? So what it does is, in the first step, as you can see, it will break down S into NP and VP. Then what does it do? Now the top level has been, decomposed into two. Now it goes to the two lower phases, or to the two lower subgoals. It will look into NP and VP. So it takes NP and it tries to find another constituent that can substitute NP. Okay, so it looks for the left-hand side and substitute it with the right-hand side. That's what it does. Then NP NP has three different possibilities, options. The first one is NP can be further, decomposed into determinant, noun, and prepositional phrase. NP can also be, at another option, can be decomposed into a determinant and a noun. Again, NP can also be the word I. So what does it mean? Your recursive descent tries to, check each and every one of them, one by one. So it takes the first one. NP So when you press a step, NP, it would divide it into, it would decompose it into three based on the first one. Mind you, if this doesn't work, that's why we say the recursive distance tries to look for all possible solutions. Now the first element in here is a determinant. Determinant in the left hand side, it tries to substitute it with the right hand side. So determinant either it can be the or it can be a. So now what is the? Now the is a terminal. How do we know it's a terminal? Because you don't find it on the left-hand side. If something is a terminal, terminal means the end point, then you cannot find it on the left-hand side of your grammar. It's a word. If it is a word, then it must be one of the words that's provided by the user. So what does it do? Check ያደርገዋል. So it's successful now. Now what does it do? The next step is now. So it will try to see all possible nouns. So it takes the first one, ማንን ይወስዳል? It takes man, but when it compares it with the word, that's the next word that we have in the structure, it doesn't match. ስለዚህ ምን ማለት ነው? It goes back to the other option. Okay? ስለዚህ ወደ ሌላ ኦፕሽን ይሄዳል። ማንን ይወስዳል? The next one is park. Okay? Parkን ይወስድና ቴስት ያደርገዋል። Compare ሲያደርገው it doesn't match. But mind you, those that are attempted, those that are tried would be marked with, tried, because the grammar, the parser tries to match them, but it was not successful. ስለዚህ መሞከሩን ኢንፎርሜሽን እየያዘ ይሄዳል ማለት ነው። ቀጥሎ ማንን አገኘ? ዶግን አገኘ። the dog match. ስለዚህ it goes to the next one. ማንን ነው የሚያየው? Prepositional phrase. But what is a prepositional phrase? It is a preposition followed by a noun phrase. ስለዚህ ይበትነዋል. Then it goes to a preposition. Okay? Preposition ላይ ሲደርስ ኢንን አገኘ፣ አልተሳካም. Okay? It takes under, አልተሳካም, because as you can see, the next word is so. So it fails. ስለዚህ ምን ያደርጋል? Within ይሞክራል፣ አልተሳካም. So what does it mean? Yeah, it was not successful. Okay? So what it does is it goes back to the other one. Then it looks with a telescope. it goes on like this. ስለዚህ ልክ ይሄ አልሳካ ሲለው በኤም ይሞክራል by the way በዘ ሞክሯል አይደለ? It's going to test it with a. ካልተሳካስ it goes back. Now what does it mean? Noun being decomposed into determinant noun and noun phrase has been tried and it was not successful. So what does it mean? It goes to the next option. What is the next option? Determinant with a noun. ስለዚህ እሱን ደግሞ ይሞክራል ማለት ነው። So it goes on like this. I'll put it using auto step, okay? So that you will see the whole animation, okay? So as you can see, it keeps on attempting each and every possible structure, okay? Each and every possible structure based on this one. As you can see, all words, all structural elements, all non-terminals are going to be attempted, okay? By the way, this is a demo. The demo is important to show you how the parser works. Your assignment today is going to be, I'm going to give you a sentence and you are expected to develop a grammar to perform such kind of parsing. I'll show you how to do that on Python. Then I'll give you an assignment for you to exercise on. So as you can see, all possibilities would be attempted. Now have a look. You see? Now one structure has been accepted. As you can see, the structure has this grouping. ምንድን ነው የሚያደርገው? The dog የሚለውን እንደ አንድ ግሩፕ ወስዷል። ቀጥሎስ in the park የሚለውን as a preposition ወስዷል። so የሚለውን እንደ አንድ፣ a man የሚለውን እንደ አንድ። ቀጥሎስ so a man in the park የሚለውን as one verb phrase ወስዶታል. And the dog and this verb phrase is going to create or form a sentence. We have another way. ዝም ብለን ቀጥል ብንለው it's going to give us another structure as well. Okay? Have a look. እዚህ ጋር ምን አለ? prepositionኑ ለብቻው ነው፣ the noun phrase ለብቻው ነው፣ verbu ለብቻው ነው። እነሱን አንድ ላይ ነው combine ያደርገው. Don't forget this structure. auto step እንበለው እንደገና። So mind you, it will always track back. Whenever you can see the operation in here, the operation on the bottom, it tells you whether it's expanding, creating a match, or backtracking. And backtrack, match, expand, backtrack, match. Match የሚለው whenever it tries to compare it with the words. Backtrack የሚለው when it fails and tries to look for another option. Expand ማለት ደግሞ it means it will expand. Now have a look at this one. This is another structure that is found to be valid in this sentence. ምን አለ ግን? Instead of in the park የሚለውን እንደ አንድ preposition ይዞ ከቨርቡ ጋር ከማገናኘት ይልቅ ከማጋ አገናኘው። Determinant noun እና prepositionen it combined as one noun phrase. ስለዚህ ምን እያለ ነው አሁን እዚህ ጋር? The dog saw. ምንድን ነው ያየው? ውሻው ምንድን ነው ያየው? The man in the park. ፓርክ ውስጥ ያለውን ሰውዬ ነው ያየው ነው የሚለው። Okay? The other one, the previous one ምን መሰላችሁ የሚለው? The dog saw a man. የትኛው ውሻ ነው ስትባሉ the dog was in the park ማለት ነው. In this case it is a man who is in the park. So as you can see the grouping እዚህ ጋር noun phrase ሰጥቶናል አይደል? What is this noun phrase? ምንድነው noun phrase? A man in the park ነው የሚለን. It means it tells you that it is a man who is in the park. In the previous cases the preposition was part of the verb. What does it mean? The dog saw ማንን ነው ያየው? A man. Where? In the park. So it is the dog who was in the park ማለት ነው. So this is the main difference that we have. By the way, on this demo, you can go to edit and you can edit the grammar or the text as you wish. Okay? Grammaruንም ቴክስቱንም ኤዲት ማድረግ ትችላላችሁ። ለምሳሌ ቴክስቱን ኤዲት እናድርገውና እንደዚህ እንበለው። A dog C እንበለው። Sees a man in the park እንበለው። Apply. Okay? Okay, እንበለውና let's do this one. Auto step እንበለው። ያችሁ a dog sees a man in the park አለ። As you can see, we don't have a word which says sees የሚባል ወርድ የለንም እዚህ ጋር። ያችሁ ስለዚህ ሞክረና ምን ያደርጋል? እሱን ሲያጣ it says I was not able to produce any structure for this sentence. ያችሁ any verb ያገኘው it doesn't match with sees because the only verbs that we have is ate and so ነው። ከዛ ውጭ ያሉትን understand አያደርግም። ስለዚህ ምን አለ? It finished and it didn't create any structure ማለት ነው። So what does it mean? It means either this sentence is wrong or this grammar is not complete ማለት ነው። You can also change the grammar if you want to. Okay, grammar ልለውጠውም ካላችሁ እዚህ ውስጥ ገብታችሁ ሴንቴንስ ማለት NPVP ነው። NP ማለት የሚለውን ነገር you can change it as you wish። እዚህ ጋር መጣችሁ ለምሳሌ instead of this one I can say እዚህ ጋር መጥቼ cease ብዬ ጨምሬበት ኦኬ ከጨረስኩኝ በኋላ I can say sorry. Oh, sorry, you are not able to see the update አይደለ? This is what we mean by the editor. Sorry, አላሳየዋችሁም። ኤዲት ብላችሁ grammar ስትሰጡት this is where you are going to arrive. So ምን አደረኩኝ እዚህ ጋር cease የሚለውን ጨመርኩበት። በፊት አልነበረውም c። ከዛ በኋላ I would say apply and okay. Then after that, just a moment. Then after that, I will come back to my demo. As you can see, the word cease is included in here. Okay. Then auto step below in here. Okay, it's finished. So let's restart it again. Okay. Just a moment. Okay, let's edit the sentence as if it's a new one. Okay, apply. Okay. Then you can say auto step. So as you can see, it says the dog sees no kadam. It says it was wrong. Now let's see what the output is going to be. Because we changed the grammar, which means we included the word in the grammar, then the sentence should be valid. Okay. Previously, it says it's finished with failure because it was not able to find the verb, I mean, the word in the sentence. That was the gap that we have identified. Okay. Now we are going to have, this is a step where we are going to have the solution, okay? The noun phrase is going to be substituted with, with the determinant and the noun, yeah. Now you see, this is a solution that we have. A dog sees a man in the park below, solution is ይሰጠናል ማለት ነው. And this happened because the word sees was included as a verb in our grammar ማለት ነው. So the most important element in parsing is building this grammar very carefully. Okay, that's what we have. Now let's move on to the next one. Okay, let's move on to the next one. The next one is how to do the same thing using shift reduce. Okay, so let's see if everything is closed first. Okay. Yep. Okay. Now for the bottom-up approach, which we call is the shift reduce, then we are going to use the same kind of demo, but with a different name. We call it, SR parser. Nominal. This is shift reduce. The previous one was recursive descent. But this one is shift reduce parser. So again, when you do that, another window is going to open up. Now you can see that it's of a different type. The method, the interface or the menu is also different. So as you can see on the left-hand side, we have a grammar. Now the sentence, instead of having it at the bottom, we are having it at the top because this is a shift reduce. And the idea in shift reduce is it will bring a word to the working area and it tries to substitute the right-hand side with the left-hand side. Mind you, in shift reduce, it tries to substitute, this is what it does, okay? In shift reduce, what it does is it will try to substitute the right-hand side with the left-hand side. So whatever it has, it will look for it on the right hand side, and whenever there is a match, it will substitute it with the left hand side. So that's how it is going to happen. So shift reduce, as we said previously, it starts with the word itself. So steps to this word, which is the word my, is going to be brought to the stack. Instead of, from the text, it would be brought to the stack, because the stack is where combination of word or constituency is built. ስለዚህ steps እንለው my would come here. Mind you, mine የት ነው የሚፈልገው? As we said, it will look for it on the right hand side. mine አገኘው። ስለዚህ ምን ማለት ነው? my ከተገኘ it can be substituted with the determinant ማለት ነው። automatically substitute ያደርጋል። So we don't have anything to work on in the stack. ስለዚህ ምን ያደርጋል? It will bring the next word again. dog ይመጣል። dogን ሲያገኘው it's a noun, so it will substitute it in such a way. Okay, it will substitute it in such a way. Then after that, what's going to happen? It will look for determinant and a noun. Mind you, constituency is about adjacents. Okay, those constructs should be adjacent to one another. So it looks for determinant and a noun. Determinant and a noun ሲያገኝ ምን ይሆናል? It is a noun phrase. ስለዚህ ወደ noun phraseነት ይተካዋል. Then it doesn't have anything to work on, so it will bring another word from the text. So ያመጣል. So is a verb. Now it looks whether noun phrase and a verb are ordered in such a way. እዚህ ጋር ብታዩ, there is no structure that combines noun phrase with a verb on the right hand side. ስለዚህ ምንም አያደርግም. It keeps on taking another word. A ወሰደ. A is a determinant. So again ምን ያህል noun phrase verb እና determinant አለ ወይ? verb እና determinant አለ ወይ ብሎ ቼክ ነው የሚያደርገው. Always it looks for adjacent constructs. ምንም ስለሌለ it keeps on bringing another one. ማንን ይዞ መጣ? ማን ምንድነው? noun። ቀጥሎ ምን አገኘ? determinant እና noun is a structure, so it will substitute it with a noun phrase. Then after that, verb and a noun phrase አለኝ አለ። ስለዚህ አገኘ። ቀጥሎስ noun phrase and a verb phrase is a sentence. Now you have this one. Now as you can see, it reaches the sentence or the top goal. Okay, it reached the top goal. But the problem that we have is still we have other words that are not yet part of the structure. ስለዚህ ምን እያልን ነው? The grammar is wrong ማለት ነው። ስለዚህ ምን ያደርጋል? ሁሉንም word ለመውሰድ ይሞክራል, because every word should be considered. Okay, ሁሉንም ለመውሰድ ይሞክራል። ከዛስ ምን ሆነ? Now this is where we have, and it says it's a failure because it should create one tree, because every word that you have in a sentence are trying to build one concept. So they have to arrive at one top level root, which we call is S. ስለዚህ fail አደረገ ይላል ማለት ነው, because it didn't actually reach the level that we wanted to reach, because እንዲሆን የምንፈልገው ምንድነው? Every word is considered and you have only a single tree. But in our case, how many trees do we have in here? ስንት አለን? We have 3 trees, አይደል? One tree, another one, which means we are having a forest rather than a tree. And it will say it's a failure, because in a sentence, in a structure, what you need to have is, in a sentence, you need to have only one tree, and that tree is going to carry one context or one concept in the whole structure. So this is what we mean by the shift reduce and the shift reduced and the recursive descent parsers. Okay, is the concept clear? ግልጽ ነው?
Yes, it is.
Okay. ጥያቄ ካላችሁ, if you have any question?
Hello.
Yes.
Normally አሁን ቴክስት ወርዶችን ሲወስድ ማለት ነው ቶፕ ዳውን ላይ
እሺ
ሄሎ ወርዶችን ሲወስድ ያው ነው
ከሺፍት ረዲዩስ ማለት ነው።
አዎ
እሺ
ዳይሬክትሊ ለምን ከሴንቴንሱ መውሰድ አይችልም? ወጥ ሴንቴንሱ ላይ ያሉትን ወርዶች ያመጣ
እኮ ከዛ እኮ ነው የሚወስደው። ከዛ ይወስድና
ማይ የሚለው አሁን ለምሳሌ የለም አይደለ? እኛ ሴንቴንስ ውስጥ
ምን የሚለው
ማይ የሚለው
የትኛው ጋር? የመጨረሻው ላይ ነው ያለው? የመጀመሪያው ላይ?
የሁለተኛው።
ኦኬ፣ የሺፍት ረዲዩሱ ላይ።
ያ
ኦኬ፣ አንዴ እንሂድና አንዴ ልክፈተው፣ ሼር ላድርግላችሁ መልሼና ይሄኛው ነው አይደለም የምታየው? አለ እንጂ ይኸውልህ፣ ይሄ አይደለም። ሌትስ ሲ ምንድነው ያለን? ስቴፕ ስለው ማይን ወሰደ። ማይን እኮ እዚህ ጋር አግኝቶታል። ክሊር ነው?
ያ
ስለዚህ ማይን ስላገኘ ማይን ግን ምን አደረገው? it substituted with a determinant.
So what is the solution? አሁን ፌል አድርጓል የኛ አሁን ፌል አደረገ አይደለ?
ፌል ያደረገው ለምንድን ነው? either the grammar is wrong or our sentence is invalid. Mind you, we said parser is going to give us two benefits. One, it will recognize the sentence. If it was wrong, then it will say it is wrong. አሁን በዚህ ጊዜ ምን እያለን ነው? This sentence is not recognizable by this grammar እያለን ነው. So either the grammar is wrong or the coverage is weak or the words that I have in the sentence were not put in the right order ማለት ነው። አሁን እንግሊዘኛ ማወቃችንን እንቶ we know that my dog saw a man in the park with a statue የሚለው ትክክል ነው። ነገር ግን ግራመሬ ጎዶሎ ነው ማለት ነው አይደለ?
Okay, so the problem is with the parser ማለት ነው።
No, with the grammar. ይሄ ግራመሩ ማለት ነው። This is where the problem is. ፓርሰሩ ይሄንን ነው ኢንተርፕሬት የሚያደርገው።
ያ
ኦኬ
ኦኬ አሁን አግኝቻለሁ። እሺ እሺ ቴንክ ዩ።
በኋላ እንሰራለን ግራመር።
ኦኬ እሺ እሺ
Any other question? Okay. If you don't have a question, then let's go to how we can make this one to be practical. Instead of seeing only the demo, let's see how you can also build your own. Now, in context-free, in parsing and in grammar, we have two types of grammars. We have seen it again in chapter 2, if you remember, when we discussed syntax. We have context-free grammar and probabilistic context-free grammar. So the grammar is the most important element for the task of parsing, okay? That's what we do. Okay. So first you have to understand the concept of what we mean by context-free grammar. As the name indicates, context-free grammar doesn't look into the context. It just looks into the constituency, which means the part of speech and how the part of speech are combined to one another. So this is a very simple context-free grammar that you can use to understand how it works. Now, if you want to develop a parser, what you need is to build such kind of a knowledge base. Mind you, this is a knowledge base. And what kind of information do we have in this knowledge base? Let's start from let's start from the right hand side. Okay, as you can see on the right hand side, what do we have? Let's change the color. Okay, what do we have on this side? On this side we have the words in my language. Mind you, let's assume that this is my language, which means these are the only words that I know ማለት ነው. So the language understands only the words that exist in the grammar. Okay, that's why whenever you write on word processor, if you put a word with a spelling error, then it cannot check the grammar. Once you correct the spelling error, then if a spelling error is corrected, the word is going to be valid, right? Then after that, it checks whether that grammar is, or that sequence of words is allowed or not. So as you can see, what it says is, I have 4 types of nouns, which means people, fish, tanks, and rods are nouns. Then it will also say I have 3 types of verbs in my language, which is so, eat, and kill. And I have 1 preposition, which is will, and I have 1 adjective, which is small. Then after that, here, we have a constituency rule. And the first one, it says, a preposition followed by a noun phrase is a prepositional phrase. An adjective followed by a noun is a noun phrase. A noun itself can also be called a noun phrase. Noun phrase followed by a prepositional phrase is a noun phrase. A noun phrase followed by another noun phrase is also a noun phrase. A verb followed by a noun phrase followed by a prepositional phrase is a verb phrase. So this is what we have. And you'll get most of this thing either from knowledge of the linguistics, or you can get it from the corpus. From a tagged corpus, you can actually collect some part of your grammar. So this is what we mean by a phrasal structure grammar, which is very important for parsing. So In a context-free grammar, we have these 4 variables or parameters. So a grammar contains T, N, S, and R. T means the terminals, and what we call a terminals is the words in the language. N means non-terminals. Non-terminals means they can be broken down into smaller pieces. They can be substituted with something else. So N is a set of non-terminals like NP, BP, S, የምንላቸው በሙሉ are non-terminals because you can break them down into smaller pieces. The terminals are only the words, the lexicons that you have. And S is a start symbol, which you find it in the top. And R is the production rule. And the production rule is of such a form. ምን እያለን ነው? X can be substituted by gamma እንደማለት ነው. So whenever you put such kind of a thing, like in a grammar, we have seen it in our previous slide as well. If I say a noun phrase, then an arrow, አስቀምጬ, a determinant and a noun, አልኩኝ ማለት ነው. If I find NP, I can substitute it with determinant and a noun. Or if I find a determinant and a noun, I can substitute it with NP. And I can do this without understanding the context, without looking into the words. ለምሳሌ ዲተርሚናንቱ ማን ነው? ናውኑ ማን ነው? ናውን ፍሬዙ ማን ነው ሳልን I can perform the substitution. That's why we call it context free. It doesn't look into the context of the words. It doesn't look into the context of the structure. It simply performs the substitution of the left-hand side with the right and the right-hand side with the left-hand side. That's why we call it a context-free grammar, okay? Then, what at the end, if you have this structure, mind you, a context-free grammar has 4 parameters: terminals, non-terminals, a start symbol, and grammar rules ማለት ናቸው. The terminals are the words, the non-terminals are those that can be decomposed. S or the start symbol is a root of your tree, and R is a substitution or the production rule that we have. So with this, you will say the grammar G generates the language L. So what does it mean? Everything that the grammar generates is a valid sentence, and every sentence in the language should be understood or interpreted by the grammar. And this is what we have in a phrasal structure. Now, the point is, some of the structures are ambiguous, right? ለምሳሌ አደገኛ ፈረስ ጋላቢ የምንለው is ambiguous. So which one am I referring to? Am I referring to, I mean, as dangerous? Am I referring to the horse or the rider? That's the challenge that we have. And to resolve such kind of ambiguity, what we have is probability as a solution. So in a probabilistic context-free grammar, as you can see in the title, we have added 1 parameter, which is P. In addition to the 4 parameters, which is terminals, non-terminals, start symbol, and production rule, we are going to have the 5th parameter, which is a probability function. And the probability function is going to tell you how frequent something is over the other option that we have. So you can have, for instance, 2 ways of creating a noun phrase. You can say a noun phrase can be created by a determinant and a noun, or you can say a noun phrase can be created by a noun followed by a conjugate and followed by a noun. You see? What does it mean now? In my language, I have 2 possible ways of creating a noun phrase. So let's see, on the structure, if I find a noun phrase, ምን ልበለው? Shall I call it determinant and a noun, or noun conjugate and a noun ልበለው? So this is ambiguous, right? Because both possibilities are there. In a probabilistic context-free grammar, in addition to this, you are going to have a probability, ለእያንዳንዱ, okay? So what is the chance of having determinant and a noun creating a noun phrase? So you might say this is 0.7. What is the probability that noun, conjugate, and a noun creating a noun phrase? You can say 0.3. Mind you, the total must be 1. For a single left-hand side, the total should be 1. So let's see, 0.7 and 0.3, it's going to be 1. So what does it mean now? If I find a noun phrase, then it is more likely that it is a determinant followed by a noun. So let's see, you can disambiguate based on the probabilistic value that you have. And that's what we mean by probabilistic context-free grammar. Mind you, we have 2 types of context-free grammar. The first one is the basic context-free grammar, where ambiguous structures are going to be generated as much as they exist. But in the case of probabilistic context-free grammar, from those possible solutions, it's going to pick the one with the highest probability score ማለት ነው. And that's what we mean by disambiguating a structure. ስለዚህ የትኛው structure ነው ሲባል, the probabilistic context-free grammar will say that this is a more likely. And how is that calculated? Using the probabilistic score ማለት ነው. One thing that we know, the probability score will always be between 0 and 1. Okay, will always be between 0 and 1. And the sum of all probabilities is going to be 1 ማለት ነው. The probability of ድምር ከአንድ መብለጥ የለበትም. As you can see, for a noun phrase, the total probability score is 1 ይሆናል. For a verb, we are going to do the same thing. For verb phrase, we are going to do the same thing ማለት ነው. So we say the grammar G generates the language model L. But mind you, in here, probability is the addition that we have. So in a probabilistic context-free grammar, this is how we are going to model it. ቀደም ትዝ ይላችሁ እንደነበረ ይሄ እነዚህ አልነበሩም. We didn't have these elements, right? የቀደሙ ላይ we didn't have these elements. But now we are going to have the probability score for each of the constructions or each of the rules that we have. So what we are saying is, to create a sentence, we have only one option, which is a noun phrase followed by a verb phrase. What about to create a verb phrase? To create a verb phrase, you have two options. One is a verb followed by a noun phrase, the other one a verb followed by a noun and a preposition phrase. So as you can see, the sum of these two is 1. The sum of these three is 1. And because I have three ways of creating a noun phrase, I have one way of creating a prepositional phrase. I have 4 different type of nouns. As you can see, the sum is 1. And 3 type of verbs, the sum is 1. 1 preposition, which is 1. And 2 adjectives, which is again 1. So this is a probabilistic context-free grammar. When we come back, we are going to see how it's going to be used. Okay, please join the meeting once more.